Say you're presented with a website and something just doesn't sit right with you. Maybe it's in a language that you can't understand, or maybe it's vulnerable and can be hacked. But thankfully, you can do some research and dig a little bit deeper. And that is exactly what we're going to do in this video while I showcase this application to you called ZDir, or Z Directory, I'm not quite sure. Looks like it's listing just a couple different files, things that might be accessible on the file system of a Linux server. And it's in a language, again, I can't easily read, so thankfully we can just translate that, right? Let me go toggle this thanks to Google, a little bit of Google Chrome magic, we'll swap that over to English. Now this makes a bit more sense to me, and it is just as we expected. Hey, some files listed with their file size, maybe a timestamp, and we could probably dig into each of these, figure out what they are. I see this config.ini file that looks like just a simple configuration file, again with some characters that I can't read, but it looks like this is all for ZDir, this application. Maybe running internally on port 6080 in release mode with a public path for storage information, things that might be worthwhile to know. However, there aren't any users defined at the very bottom here. Looking back in the file listing though, there is another file here called passwd or password, and this just looks like a regular /etc/password file for a Linux distribution or operating system, right? This lists out all of the potential users on that endpoint, on that device, on that computer, and this is interesting. Maybe this is worthwhile information. Looks like there is a user account created on the system, user ID 1000, so we can assume that's a regular interactive user with a home directory in /home/user. So just the normal setup here. So this looks weird, right? You don't normally see those files or that sort of information just publicly exposed on the internet. At least it shouldn't be, right? But let me tell you, this is one of the capture the flag challenges or training exercises and activities that I created and put on with Sneak and their Fetch the Flag CTF competition that I co-hosted. And of course, Sneak could help you solve this challenge alongside many others and just looking for vulnerabilities within your code, but we'll chat about that more in a little bit. But first, now that we know that this is a capture the flag challenge, obviously something is vulnerable here. This application, this can be hacked. This brings us to a GitHub page, and this clues us in. Look, this thing is actually open source. It's out there for free on the internet, and we could actually dig into all the source code and understand how it's made. Granted, a lot of this is, again, in a language that I don't read and can't speak, so we might need to do a little bit more legwork here. I am a bit curious, though. Can we find any information just by simply Googling this or doing some quick research, trying to see what we're up against? And I see maybe a Python library, another project here. Oh, but there is a CVE that sticks out to me around January timeframe of this year. Let's dig into that. Turns out there is an arbitrary file upload vulnerability in the /API/upload component of ZDir that allows attackers to execute arbitrary code via a crafted .ssh file. Now that's specific to version 3.2.0, but maybe that's what we're up against. This does have a high severity score. This could potentially be like code execution in full application takeover, right? And hey, check it out. Sneak is tracking the exact same thing. Arbitrary file upload with a high severity score, and it explains ZDir is a directory listing program. Everything that we've seen. Exact same setup here, but they do reference the GitHub commit and the GitHub issue that might be able to give us a little bit more context. By the way, super quick, this video is sponsored by Sneak, and I'm super grateful for all their support, especially in co-hosting the Capture the Flag. But if you want to see how Sneak might be able to find vulnerabilities, weaknesses, and issues in your own code, applications, and projects, seriously, please take a look. Link in the video description. Check them out. They can do some incredible stuff for free. Now let's take a look at that GitHub issue, the one that was linked and referenced. It takes us right to the exact same GitHub repository that we were just previously looking at. And they say here, look, this file upload with an SSH or authorized keys file can cause RCE or remote code execution. They do offer some steps to reproduce using that specific version 3.2.0 where they pull down the repository, run the application. Maybe in the configuration file they have, a public path present there, that data/public directory that we saw just as well on our own target instance, and they start up the application. You'll need to view routes. The interface does require login credentials. So with that, maybe we need to be authenticated. Let's go back to our application and see, can we even log in? Up in the right-hand corner of the navigation, looks like there is a login button, but that takes me to ZDir initialization. Maybe that's because there aren't any users already created, right? Can I just create one like testing? And I guess I can use the exact same username as the password here, just testing all around. Password does not meet specifications. Please enter a combination of 8 to 6. Okay, whatever. Let's just use fancy pass, capital P, @SSW0RD. Let's see if that will work for us. Cool. Okay. Yes, thank you, Google Chrome. I know that is a weak password. Oh, now I suppose I have the administrator login because that was the first user account ever created. That's fine. We probably don't have a whole lot of other administrative capabilities here. Ooh, but we can read some interesting stuff. Maybe some server information. Operating system is Linux. Yep, AMD 64 architecture, number of CPUs, whatever. I think we can still get to the front page, which is just a regular application, right? Our config.ini and password file are listed here, and we could interact with it. Now that we're logged in, looks like we have more functionality even. Hey, maybe we could create something. That plus sign might be like create folder. I guess I don't know. Let me just add a test here. How about that? Yeah, okay, cool. Creates a folder, and we could, of course, upload. Looks like that's available in the navigation, and we could drag and drop or browse to a file here. Now that we can finally interact with the application, let's go review that GitHub issue and see where things go wrong. They include some screenshots, the underlying code, the source code in Golang of this application, where you can see all the different routes, and of course, we have access to this just as well, right? We have the GitHub repository and all the source code. Looks like if we were to create a directory, like the controller.makedir method, the parameters substituted by the post request are the name and path. So we could supply those, as we just kind of saw interactively, but it looks like it's only going to determine whether or not something is passed is a folder or not. So with that, we could create a .ssh directory using directory traversal, using a quick trick where we .. climb up the file system and potentially place any folder wherever we want on the file system. Let me be clear, this is a vulnerability, right? That's bad. We shouldn't be able to put a file or folder or whatever on any arbitrary location on the device and endpoint. They include a couple Burp Suite screenshots, so you can see this in action. They actually demo and offer a little proof of concept where they're posting to this URL API dir create to create a directory with the path and name parameters provided. Obviously logged in with the username and a specific token in their cookie, and that succeeds. Now, if we were to actually upload a file, we could specify the upload path, the location where that's going to land on the file system, and since we just created a directory, we could maybe just throw it in there, even an arbitrary location. The thing is, we can see in the upload code, in that method and functionality, they do test this against a regular expression pattern. They try to check, hey, are there any periods included in this string, like a .. syntax to kind of traverse the file system. This is added as a security mechanism, something as a protective layer. Problem is, it doesn't work all that well. Because you can see this regular expression, the very start of the syntax with the arrow or the caret, that means the start of the string, the very, very beginning of the data that's provided. It looks for a literal period or a dot, or with the pipe symbol, vertical line, they're inside of parentheses, or ... the two periods, and anything that follows with a dot and then a plus sign, one or many of those, right? Here's the hiccup though. You could still supply a path like an absolute path that doesn't start with a period or a dot, it's just the /. Their write-up references just as well. There is a loophole in the regex to determine whether a path is legal. You can just use /.. to bypass that. Here they showcase their HTTP post request yet again, going to API/upload, providing a file given an authorized keys for SSH, and then just using the actual contents of the SSH key, right? Now, in this scenario, when HTTP, the service and the actual listening functionality of ZDIR, is paired with and in combination of SSH, that secure shell, this is bad. That can be, that remote code execution vulnerability because we can stage our own SSH access key. This is awesome. This is great. These are all of the puzzle pieces and the breadcrumbs that we need to be able to go tackle this challenge. Now, if you know me, you know I don't like dealing with Burp Suite, so I want to try to write this in Python, and we'll just use requests and automate our way into creating the folder and the file and then being able to get access. Actually, in case you didn't see it, it's pretty cool to see the creator and the author developer response to this. They say, hey, I've updated the code to make sure this is fixed. Here's the change. You can link to the commit here and we'll go ahead and see that in action. This is kind of neat just to scroll through. You can see the changes that they made, especially trying to remove that regular expression pattern that was weak. And then it just kind of matches for things and digs into it a little bit more. Now let's go write some code and exploit this. So just to figure out the process here, let's try to log out of our current instance of Zder, and then let's open the network tools or developer tools with F12 over on our keyboard. So with the network tab on, we can now go to log in and see some of the traffic that comes through here. And then we can also try to log in. Let's enter the credentials that we just created, testing and fancy pass, and I'll hit login here. Looks like that is a login successful. So, ooh, dang it. Okay, I didn't have preserve log on, so I want to see that one more time. All right, let me toggle preserve log over at the top and testing fancy pass. Okay, so now we can see a post request to API user login with the payload just being our username and password. So that should be all that we need to log in, and we can recreate that in Python with code. I'm inside of my Kali Linux virtual machine as usual. I can fire up a terminal and let's make a directory for us to work in. I'll call that Zder and then hop into that directory and I'll create just a little playground.py script in Sublime Text to my editor here. Now with that, I'll add a shebang line, user bin environment Python 3. We know we're going to be working with some of HTTP requests, so let's import the requests module and library here, and we'll create a session object. We'll just call that S, little variable name, super simple. We could probably do a with statement or a context manager, or we can just do s.close at the end. That's fine. I don't care. It's a CTF script. Now the URL, we can create a variable for the address that we want to reach, the actual target, and I am running this on localhost just for the sake of demonstration, but we want to have that staged so that I can then do a post request with our session to our URL at that. I'm just going to concatenate these strings together with the API user login endpoint that we just saw. Now we'll need to supply some data, correct? That will just be a dictionary for our username being that string testing, and then one for our password being fancy pass, correct? There we go. Now, honestly, we could probably stage these as some variables. That might be fine too. There, okay, now we just made that a little bit more abstract and we can keep cruising. Let's see if that works to begin with. Can I go ahead and print out my s.cookies? Let me see, do I have a valid session after I've made that request? I'm gonna hit Control B on my keyboard just to run this script, and I don't currently yet. That's a bummer. Let's store that as a response variable, just R as the object here. Let me go ahead and see, does that response actually have any cookies returned? Nope. Okay. What is the text of that? We'll do some debugging in the moment here. That is true. And oh, okay. Looks like it actually returns our username, a CID, and a token. And since that returns all those objects just as like a JSON response, right? We could actually convert that into JSON, steal it here, and then maybe pull out the data, right? Because that should be all that we actually need for our session. So we could just set our session cookies. Let's go ahead and update that with the response JSON data and have that all filled in there. Let me see if that will work. Can I print my s.cookies and session cookies following that? I can. Cool. So then that should all be staged for me. Let's try to validate that we are signed in just to start. So let's just do a r equals s.get with our URL, and let's try to validate, hey, what is the response that we get from that? We don't need to display the cookies anymore. I just want to see the text response and the raw output of retrieving the home page after we are logged in. Looks like HTML here. Zder displays all of this stuff. Did that not work? It's still not displaying anything. Is it done with JavaScript? Here, let's just see if we can reach the admin page, right? That was just /admin, I think. Here, let's try and run that and see if we can see that returned. Oh, well, requesting the admin page does give me some admin.js and admin.css files. So it didn't redirect me or send me to what would be the login page. I think we're okay. I think we're in a good spot, and maybe we can keep cruising to actually go try to work with the API and then create our own folder, right? With that, let's try to think through the plan of attack here, because we know from the files that were displayed in this Zder instance that there is, based off of the etc password file or PASSWD file that we saw, there is a user on this server, in the backend application here running, that's called user, and it has a home directory /home/user. So we can create the .ssh folder for that user and then upload and create our own SSH authorized keys file, right? Let's try it out. Let's look back at the GitHub issue to showcase their workflow. They just post to dir create with the path and name. So let's see if that will work for us. Let me get back to Sublime Text. We no longer need to retrieve the admin page, but we can try to do an s.post with the URL plus API dir create. And the data that we'll provide should simply be the path, right? And that should be the ... etc., going all the way up to the home user. Now, I'm just adding a ton of these because I don't know exactly how many we need to climb up the entire file system, but hey, we'll just be generous and add as many of those as we can. We'll supply the name, and that should simply be .ssh, correct? Now that will return out that R object, so let's try to see what our r.text response is. Now when I run this with Control B, okay, 403 message something is wrong. That didn't work. Let me look back at their write-up here. The only other thing I'm curious about are these X token and XCID headers. We saw those within our cookie, right, as we were trying to interact with the service, so maybe all we need to do is supply those just as well as our own token and our XCID. Let's build out those headers. Let me create a headers little dictionary here. We can say that XCID should equal s.cookies as we filled that out now with the CID value. And we'll do the exact same thing for our X token, right? We'll bring that to X token and that token. Does that work? Let me try now to print those headers just to make sure that they exist the way that they should. And we can also supply those in our post request, correct? That should stage it just as well. So let's try to see if both of these things come through here for us. Looking good. Okay, XCID, as the dictionary here, is set to what was created for the session. Same thing with the token value. And now we have a 200 response status code, message success. So we've created that directory. Now we just need to put our .ssh file there. Of course, though, we need to have our own SSH private key and a public key, the authorized keys or IDRSA, idrsa.pub that we can place and put there. So let's get back to our terminal and let's try to simply run SSH keygen. We'll create a public and private key pair. We can just put it in the current directory, IDRSA. No passphrases needed, no passphrases needed. It'll go ahead and create the IDRSA private key, IDRSA public key, and the contents of the public key is exactly what we would need to use as the authorized keys file for the victim and the target server, right? So now what we can do is go back to our script. Let's go ahead and clean up the headers display and the r.text from our past post. But let's try to open up our idrsa.pub file. We can just kind of read the contents as a file pointer. Let's just do authorized keys, contents can be filp.read, correct? Now we can make the post request to upload this. We can say R is going to equal our session.post to our URL @/API upload, and we'll supply the same exact headers as before. We'll supply data being a dictionary including our HTTP post parameters, and the only one we needed really was path, correct? Now remember that has to start with the // here, and that'll still allow us to climb all the way up the file system to wherever we need to be, probably home, user, and that .ssh directory that we just created. Now that will work just fine, but of course we still need to really upload the files here. This should be a dictionary with the name of the variable that's going to be read in as the file here, which I believe in this case is file, and we can go look back at the post request if we need to. But we can actually supply this as a tuple with Python requests, and we can give it the name of the file that we want. We'll just call it authorized keys because that's what it should be on the file system. We'll add our authorized keys contents, being the string data that we actually want, the bytes and content of the file. And then I think the MIME type, that should be text/plain. And maybe we don't even need that. It's worth kind of experimenting. But I believe that's everything that we need here to post to that. Let's do another simple print r.text and see if the response for this file upload will work for us. Let me hit Control B on the keyboard and success. Looks like it worked. At this point, we have uploaded our own SSH access key to the server, to the vulnerable machine, to the instance that had this ZDIR application that was vulnerable to this, hey, arbitrary file upload at file location that we can leverage to remote code execution thanks to SSH. Now, because that is open and accessible in the port here, we can get to it. Now, here's time for the moment of truth. Back on our terminal, we have our public key and our private key, but we can go ahead and SSH into the target. If we knew the port, which was provided for the CTF challenge, we know the username should be user at the instance. In this case, I'm running this locally for the sake of demonstration. It's listening on port quad 2, so we'll supply that there with TAC-P. Now, if I were to try and enter this, oh, hey, it's not too happy. It also probably isn't familiar with that key, so let me go ahead and remove that. Let me see if I can run that one more time. I'll enter yes, but I don't know their password. We can't enter whatever and try to get in here. We need to use our private key, right? And that's why we created that. So let me Control-C out of this. Let's go ahead and run that exact same command, but let me add TAC-I at the start for the identity, and let's use our private key that is now associated with the public key that's on the server for our authorized hosts, authorized keys. Let's hit enter, and now we're in. Nice, check it out. Check out our username. We are user at that host, and I can go ahead and look around. Of course, we are in home user. If I run ID and who am I, it's everything you'd expect. But look, I know what you're really after here. This is a CTF and capture the flag. What we want is our flag.txt file. Easy peasy. Let me go ahead and cat that flag, and there it is. We've solved that challenge. We've exploited that ZDIR application with that vulnerability that Sneak clued us in on, that we got all the help with from Sneak. Let me say, I had hoped that this challenge would be something that Sneak was a part of all along the way. I got inspiration to create this from seeing that, hey, disclosure and information on the Sneak vulnerability database, went in to go research it, got it spun up and created it, and let me actually show you the solve script. Maybe you think it's cool. This is the formal solve script for us as the developers, like the creator of that challenge. Hey, we'll go ahead and use argparse to be able to make sure, oh, we can get all the things necessary as we spin this up dynamically. We create a couple API host functions and stage our own username and credentials, where I, from cradle to grave, initialize the application by creating that user, make sure I'm logged in, actually authenticate, stage the headers as previously. But this one I'm a little excited about because we create the .ssh directory, and then within Python, I use all the silly, stupid, like cryptographic algorithm methods, functions, whatever, to stage an SSH key. With that, I have it in memory. It's not written to disk, so it's all standalone in this Python script. Then I slap it up, upload it, and I use a simple os.system to be able to shell into the SSH command. Works nice and easy for me. I know I could have done something with like Pwn tools or whatever, Paramiko, but that always gets a little bit finicky. So this works just as well for immediate interactive shell and access to get into that vulnerable application. If you're interested in some of the other Fetch the Flag CTF write-ups, whether I've created them as videos or they've been community submitted by the thousands of players that came to join the party here, thank you so much for all your support. Special thank you to Sneak for allowing me to co-host. And please, if you haven't, seriously, go give them a little look. Check out all that they're up to. Link in the video description. Thanks for watching, and I'll see you in the next video.